Dear students, in this video we are going to study about the magnetic effects of electric current, in which we are going to see about the OSL experiment, magnetic field around a straight conductor carrying current, and also about a circular loop. Then right hand thumb rule, next Maxwell's right hand corkscrew rule. Dear students, in this video we are going to study about the magnetic effects of current. Now let us first study about OSL experiment. The year 1820, Hans Christian Oersted, while preparing for his lecture in physics, noticed that the electric current, when passing through a wire, deflects the nearby magnetic needle in the compass. By proper investigation, he observed that the reflection of magnetic needle is due to the change in magnetic field produced around the current carrying conductor. That is shown in figure 3.25 here. When the direction of current is reversed, the magnetic needle is deflected in the opposite direction, and this led to the development of a theory called electromagnetism, which unifies two branches in physics, namely electricity and magnetism. So this is the diagram which shows the deflection in the magnetic needle when a current is passed through a conductor. Here in this diagram there is no current through the conductor, so there is no deflection in the magnetic compass. This means that electricity and magnetism, they are related to each other. Now let us find what will be the magnetic field around a straight current carrying conductor and circular loop. Before that, let us study about the current carrying straight conductor. In that case, suppose we keep a magnetic compass near a current carrying straight conductor, then the needle of the magnetic compass experiences a torque and reflects to a line in the direction of the magnetic field at that point. If we trace out the direction shown by the magnetic needle, we can draw the magnetic field lines at a distance. For a straight current carrying conductor, the nature of magnetic field is like concentric circles having their common center on the axis of the conductor, as shown in this figure 3.26a. Yeah, this is the photograph of the magnetic field lines around the current carrying conductor. So this is the magnetic field lines around the straight long wire carrying current. And here the direction of circular magnetic field lines will be clockwise or anti-clockwise depending on the direction of the current in the conductor. If the strength or magnitude of the current is increased, then the density of the magnetic field will also increase. The strength of the magnetic field B decreases as the distance R from the conductor increases. That is shown here in this diagram. Next we will study about the circular coil carrying current. So that will be like this. So in this diagram, this shows there is a current carrying circular conductor, and the needle of the magnetic compass experiences a torque and deflects to a line in the direction of the magnetic field at that point. We can notice that the points A and B here, the magnetic field lines are circular, and the magnetic field lines are nearly parallel to each other near the center of the loop. Like this, they are parallel. This indicates that the field present near the center of the coil is almost uniform. And the strength of the magnetic field is increased if either of the current in the coil on the number of turns or both are increased. The polarity North pole or south pole depends on the direction of the current in the loop. So here like this. Next, we are going to study about the right hand thumb rule. The right hand rule is used to find the direction of magnetic field when the direction of current in a conductor is known. What is right hand thumb rule? Let us assume that we hold the current carrying conductor in our right hand such that the thumb points in the direction of current flow. Then the fingers encircling the conductor point in the direction of the magnetic field lines produced. In this figure shows the right hand rule for current carrying straight conductor and circular coil. Here there is a straight conductor, and this is for a circular coil. Right hand corkscrew rule can be applied. Right hand thumb rule can be applied to this. Whereas for this Maxwell's right hand corkscrew rule, that is used to find the direction of magnetic field around a current.
Hi, I am James Clerk Maxwell. Here's my right-hand corkscrew rule. If we rotate a right-handed screw using a screwdriver, then the direction of current is same as the direction in which screw advances, and the direction of rotation of the screw gives the direction of the magnetic field.
Carrying conductor. And if we rotate a right-handed screw using a screwdriver, then the direction of current is same as the direction in which screw advances, and the direction of rotation of the screw gives the direction of the magnetic field. And that is given in this diagram like this. So if you rotate the screw in this direction shown, then the direction in which the screw advances will give the direction of the magnetic field. That is the direction in which the screw advances will be shown by the direction of current, whereas the direction of rotation of the screw will give you the direction of the magnetic field.